Hello student, so here in this lecture we are going to see what is the common ion effect. Okay, so what happens, I will just give you one example before proceeding to the actual concept. Suppose you are taking sugar in water. Okay, 1 tablespoon of sugar you are taking in a 1 glass of water. What happens, the dilution or dissolution of that sugar, 1 teaspoon of sugar or tablespoon of sugar, uh, is more now, suppose. And if you add 1 more tablespoon of sugar in that 1 glass of water, in the same glass of water, okay, so what will happen, the solubility of the previously added 1 tablespoon of sugar is quite getting affected. Is getting affected because now number of molecules, common ions, number of sugar molecules are increased over there. Okay, what happens here, as the number of same ions increases in a same system, the solubility of that ions get decreased. Solubility of that ions get decreased means what? See now, here is the one example. This is acetic acid. When it is get dissociated in the water, it forms acetate ion and H plus ion. Right now, what happens here? If you add common ions in the form of sodium acetate, this is salt of acetic acid, sodium salt of acetic acid. What will happen now? See, here acetate ion is common. Which ion is common? Acetate ion is common, not the sodium ion, but one of the ion is common. So this ion affects the solubility of this one. Okay, what will happen as the acetate ion increases? The acetate ion now combine with the H plus and they again shift towards the left hand side of the reaction. Okay, they shift towards the left hand side of reaction. Means what happened? The number of acetic acid ions now, the solubility of that acetic acid ions decreases and number of acetic acid molecules increases. Acetate ions decreases, but these ions are increasing. Why? Because of this, I am talking from the previously added acetic acid molecules. Okay, so these ions are combining with H plus and they are getting shifted to this side. The reason is because acetate ion is more in number here. And now acetate ion is common. So what is the definition? When a strong electrolyte containing a common ion is added, effect of added common ion is to suppress the dissociation of weak electrolyte. Okay, to suppress the dissociation of weak electrolyte, this is called as common ion effect. This is called common ion effect. Right, getting my point? So very simple. ही सारखे आयन जर पाण्यामध्ये तुम्ही समजा मीठ टाकले, काय होईल तिथे Na+Cl- होईल. ठीक आहे. But if you adding KCl in that, in the salt solution, which ion is common now here? Chloride ions are common. So the dissociation of salt, that NaCl, get decreased up to a certain extent, or its a dissociation is suppressed. Okay, and this is how the common ion effect works. So it is having its application in the qualitative analysis, inorganic qualitative analysis, that is there in your F.Y.B.Sc practical. So this is used for the separation of group second and group third elements. Group second elements are separated by using sulfide, and group third elements are separated with the help of hydroxide or as a hydroxide ions. Okay, that is there in the practical. So this is just for example to understand what the concept is. That concept is used for the separation of these ions, all these ions from these ions. Okay, if these ions and these ions are together in a solution, they can be separated with the help of common ion effect. Okay. Now next concept is a pH scale. What is a pH scale? So as we know that when we go to the chemistry lab, we see the different solutions like acids, bases, and different chemicals, right? But whenever we are starting any practical, at least we use one acid or one base for that purpose. Okay, at least. Okay, most of the time, what I can say. See now, the pH scale is a convenient acidity scale. Okay, and it is invented by Danish scientist S.P.L. Sorensen. S.P.L. Sorensen. Okay, in 1909. Okay, so pH scale is its range is 0 to 14. As you know that if the pH is below 7, you call it as acidic. If pH is a 7, that is a neutral pH, and if the pH is above 7, that is a basic pH. That is a basic pH. Okay, the pH scale is expressed in terms of hydronium ion concentration or OH minus ion concentration, and the pH is expressed as a negative logarithm of hydronium ion concentration or negative logarithm of hydrogen ion concentration or concentration of H plus ion. Okay, this is what the information regarding pH scale. This information may be there in the 11th 12th standard, but it is again mentioned over here. Okay, remember below 7 it's acidic, above 7 is a basic, and 7 is a neutral pH. And definition of pH or pH is expressed as a negative log of hydronium ion or negative log of H plus ion. Okay, in the aqueous state. Now see what is the relation between pH, pOH, and pKW. What is the relation between pH, pOH, and pKW? As we know that dissociation constant of water is given by formula Kw. We have already studied in the previous two lecture. Kw is equal to SCO plus and OH minus. Okay, if you take a negative log of both the side, you will get this equation: negative log of Kw, negative log of hydronium ion, negative log of OH minus ion. You can say here as a H plus ion also. Okay, no problem. Don't get confused over here. Okay, now see what is the pH? It's a negative log of hydronium ion or H plus ion. What is pOH? It's a negative log of OH minus ion. What is pKw? It's a negative log of Kw. So from this formula, we can write here as pKw is equal to pH plus pOH, but at 20 degree, 25 degrees Celsius, you know the value of pKw. What is value of pKw? That we have seen in the last lecture, that is negative log of 1 into 10 raised to minus 14. If we solve this, you will get the value 14 for what? pKw. You will get the value of pKw, that is 14. So putting that 14 value in this equation, you will get pH plus pOH is equal to 14. pH plus pOH is equal to 14. Very simple. Okay, I think you have understood this. Now, how the pH is measured? pH is measured by different means. Okay, one of the instrument used for the measurement is a pH meter. It is more accurate method to measure the pH of any solution. Okay, so what is a pH meter? It's a voltmeter connected to glass electrode. Okay, a hydrogen ion selective electrode. So whatever voltage produced by the pH electrode is proportional to the logarithm of H plus ions. Okay, H or H plus ion activity. Okay, and that is described by the Nernst equation. And again, one more method is there. You can use a pH indicator. What is pH indicator? You might have heard that you have used actually. Phenolphthalein वापरलेला आहे, litmus paper वापरलेला आहे. You have used methyl orange. So baraza phenolphthalein, you are using phenolphthalein as an indicator. In the acidic condition, it is colorless. If you add phenolphthalein to any solution, and if that solution is having acidic pH, means less than 7 pH, that will be the colorless. But once the pH goes above 8.3, it will show you pink color. It will show you pink color, and this is very effective range for this indicator. लिटमस पेपर जो आहे तुम्हाला माहिती आहे की ऍसिडिक जर मीडियम असेल तर तो रेड दाखवतो, रेड होतो ऍसिडिकला, आणि बेसिक मीडियम किंवा बेसिक सोल्युशन त्याच्यावर हे केलं that will show the blue color. Same is the case with this methyl orange, bromophenol blue, and methyl red. These indicators are having specific range, their specific range, pH range, in which they shows their color change, and these indicators are used for the different titrations purpose. Okay, so these are the indicator which we are going to use in your practical or the detection purpose. Okay, now see, what is pH of strong electrolyte? pH of strong electrolyte. So as we know that most of the inorganic, most of the strong acids or bases are the inorganic acids or inorganic bases. Inorganic acid माहिती आहे तुम्हाला, HCl आहे, that is hydrochloric acid, nitric acid, perchloric acid, sulfuric acid. These are the acids, they are inorganic acid. The strong bases are like, sodium hydroxide, potassium hydroxide. These are the strong bases. Okay, so this is just a brief information regarding the pH of strong electrolyte. So if you have a solution having concentration 0.01 molar, what will the pH of this solution? How you will calculate? If the concentration of this solution is 0.01, as you know that hydrochloric acid gives only one proton. Okay, so if it gives one proton, means this is the concentration of that proton. जर ते दोन प्रोटॉन असतील तर हे कॉन्सन्ट्रेशन कदाचित त्या ठिकाणी आपण वेगळ्या पद्धतीने खाली एक्सप्लेन केलं असतं. बट रिमेंबर हियर HCl gives only one proton. Okay, and yet you know the formula for pH. pH is equal to negative log of H plus ion, right? So negative log of 0.01. What is negative log of 0.01? Answer is 2. Answer is 2. So what is the pH of this solution? It's a 2. It's a 2, right? So this is how we can calculate the pH. We can calculate the pOH. We can calculate the pKW. Okay. Accordingly, in same fashion, they ask the different examples. They may change the acid. They may take diprotic acid, triprotic acid, and they will ask you to calculate the pH of that solution or concentration of any ion from that acid or base. Okay, so for this lecture, I'm going to stop here. In the next lecture, we'll continue for the concept of buffer. Concept of buffer. Thank you.